Hello everyone, I'm Pavitra from IT department and today I'm presenting my mini project titled AI Driven Culture Etiquette Guide. In this presentation, I will introduce to the project and explain the problem statement. Then I will discuss the scope, methodology, system design, algorithms used, system designs and implementation outputs, test cases, results and finally conclude with the future works references. In today's globalized world, people frequently interact with individuals from different cultural backgrounds. However, differences in social norms, communication styles, and etiquettes can easily lead to misunderstandings or unintentional offense. Traditional etiquette guides are mostly static and generic, and they do not adapt to specific regions or contexts. Hence, this proposes an AI driven chatbot that provides personalized and context aware cultural etiquette guidance, helping users communicate respectfully across cultures. Understanding cultural etiquette across different countries and regions is not easy. Cultural norms vary widely in areas such as greetings, dining, dress code, and communication. Currently, information is scattered across multiple online sources, which may be inconsistent or misleading. Therefore, there is a strong need for a centralized intelligence system that can provide accurate region specific etiquette guidance in a natural way. The scope of this project is to build an AI powered cultural etiquette guide using natural language processing. The system generates friendly explanations related to the greetings, dining, dressing, festivals, and other cultural aspects. It uses a FLAN T5 text generation model along with a custom built dataset and provides interaction between radio based interface. The target users includes travelers, tourists, students, and professionals visiting new regions. The project includes cultural information related to greetings, dining, dressing, gifting, festivals, business, and religion. NLP based location detection and intent detection are used to understand user queries. However, the system does not support real time translation, voice interaction, or live travel assistance. It also does not cover every country worldwide and is not a replacement for professional cultural training. The system uses a custom built dataset containing cultural etiquette information for multiple regions. The quality of the output depends on the dataset accuracy and the NLP model performance. Some cultural nonsense may not be perfectly captured by AI. Also, performance depends on available computational resources, especially when using from GPE environments like Google Colab. A methodology begins with data collection from reliable cultural sources. This data is then cleaned and structured into a standardized dataset. A text generation NLP model is integrated to convert raw cultural information into friendly explanation. Finally, a radio based web application is built allowing users to ask questions and receive instant AI generated responses. First, fuzzy matching is used to detect the correct location even if the user makes spelling mistakes. Next, intent detection identifies whether the user is asking about greetings, dining, or dressing, festivals, or business etiquette. A customized prompt is then built and then sent to the FLAN T5 model. The model rewrites the dataset content into friendly human-like explanation, which are validated for clarity and tone. The the architecture diagram shows the overall system flow. The user provides a query through the Gradient interface. The system performs location detection and intent identification. Relevant data is retrieved from the dataset and passed to the NLP model. Finally, a structured etiquette response is generated and displayed to the user. The use case diagram illustrates interaction between the user and the system. The user can ask etiquette related questions and select regions, view generated responses, and access category specific cultural guidance through the interface. The admin is responsible for managing the dataset. Admin functionalities include uploading cultural data, updating the etiquette information, validating API AI responses, and monitoring usage. The class diagram represents the structural design of the system. The two main classes are user and admin. These classes define the attributes and operations involved in the interacting with the cultural etiquette guide. This sequence diagram explains the step-by-step interaction flow. They show how a user query is processed and the data is received, how the AI model generates responses, and how the output is delivered back to the user. The project uses multiple algorithms. Keyword based intent detection identifies the category of the query. Fuzzy string matching handles spelling error in the location names. FlanT5 performed the prompt based checks, rewriting to generate friendly responses. Additional logic ensures correct data retrieval and response validation. The system runs on a laptop with a minimum 8 GB RAM and an internet connection. Software tools include Python, Google Colab, Hugging Face Transformers, Panda, Fuzzy Wuzzy, and Gradio. These tools were selected because they were beginner friendly, efficient, and suitable for NLP based application. The project is implemented in Python. The dataset is loaded using pandas and user input is processed to the detect intent and location. The FlanT5 model rewrites cultural data into conversational text. Radio is used to build a clean and interactive user interface. This code segment show how intent detection, location matching, prompt construction, and text generation are implemented. The final code integrates all components into a Gradio application that produces real-time AI responses. This screenshots show how the working output of the system. Users can enter etiquette relations related queries and receive structured responses. The chatbot supports multiple consecutive queries and different culture categories. Test cases were designed to validate greetings, dining, dressing, festival, and business etiquette queries. The system successfully generated accurate responses for valid inputs and handled unsupported queries appropriately. The system achieved an accuracy of 92%, precision of 94%, and recall of 91%. The results indicate reliable, context aware, and culturally accurate responses. In conclusion, the project demonstrates the AI based cultural understanding can significantly help users navigate unfamiliar cultural environments. The integration of NLP techniques and structured data sets enable accurate and friendly etiquette guidance. This system promotes respectful and confident global interaction. Future enhancements include multilingual support, deeper cultural nuance handling, real-time data updates, and more advanced NLP models. The system can evolve into a comprehensive, intelligent cultural assistant. These are the reference used for the cultural data, NLP models, and system implementation. Thank you for listening.